Hello, welcome to a new lecture on discrete mathematics. In this lecture, I want to talk about permutations and combinations. A permutation of a set of distinct objects in an order. Order is very important here. Arrangement of the object is called as permutation. A set of distinct objects, an order arrangement. In permutation, the order of object is very important. We can have like R permutation and order arrangement of R elements, and R can be any integer. For example, we have a set like S which is equal to 1, 2, 3. Right? So let's see some permutation of S. For example, 3, 1, 2 is a permutation. So the number of R permutation of a set with n elements is shown by Pn and R. For example, the two permutation of S, we have 1, 2, 3, right? 1 and 2. 1 and 3, 2, 1, 2, 3, 3, 1, 3, 2. Because order is important, so it's important. So how many do we have? 1, 2, 3, 4, 5, 6. So we show that permutation of 3 and 2 is 6. If n is a positive integer, and R is an integer which is between 1 and n, then the R permutation of a set with n distinct element is P of n and R is equal to n multiply n minus 1 multiply n minus 2 multiply up to n minus r plus 1. So how do you prove this one? Using the product rule, the first element can be used in ways. Because 1 is already selected, then the next one can be n minus 1. 2 selected, the next one can be selected in n minus 2 ways. The third one, because 3 already left, we already selected out of what we have, then we say n minus 3. And in this way, we can go ahead. Based on this one, we can have a corollary which says permutation of n and r is equal to n factorial divided by n minus r factorial. This is the equation for permutation. N factorial divided by n minus r factorial. For example, how many ways are there to select a first prize winner, a second prize winner, and a third prize winner? This one means like gold medal, silver medal, and bronze medal from 100 different people who have entered a contest. So we want to solve counting problem using counting permutation. Very simple. Permutation of n and r equals to n factorial divided by n minus r factorial. What is n? 100. What is r? 3. 1, 2, 3. So n factorial divided by n minus r factorial. You can say like this. 100, from here you can say 100 multiply 98, 9 multiply 98 multiply 97 factorial divided by 100 minus 3 is 97 factorial. This one goes, then this is their result. Another example, suppose a saleswoman, Juma, wants to visit 8 different cities. She must begin her trip in a specified city like Seoul, but she can visit the other 7 cities in any order she wishes. How many possible orders can saleswoman use when visiting these cities? Very simple. The first city is chosen because it is clearly says, and there are order of whatever you want. So 7 factorial, 7 multiply 6 multiply 5 multiply 4, 3, 2, 1. If she wants to find the tour with shortest path that visit all cities, she must consider 5040 ways. Another example for permutation, how many permutation of the letters A, B, C, D, E, F, G, H contain the string of ABC? We solve this problem by counting the permutation of 6 objects. ABC, D, E, F, G, and H. So which give us 6 factorial, 6, 5, 4, 3, 2, 1, which equals to 720 ways. The next topic here is combination. In permutation, we say that order is important, but in combination, order is not important. So an R combination of elements of a set is unordered selection. So an R combination is simply a subset of the set with R elements. The number of R combination of a set with n distinct element is denoted by C n and R. And also we have this n and r for combination, which we call it as binomial coefficients. Example, suppose we have S set A, B, C, D. Then ABC, for example, ACD is a 3 combination from S, right? You can say combination of 1, 2, 3, 4, and we want to use 2 of them, right? So 2 out of 4 is 6. Because AB, AC, AD, ABC, BD, and CD. Order is not important. Theorem, the number of R combinations of a set with n elements and R between 0 and n is combination of n and r, n factorial divided by n minus r factorial multiply r factorial. How do we prove this? Using the product rule, we say that P n and R equals to C n and R multiply P R and R. Then C n and R from here, it can be written as P n and R divided by P R and R. Then based on here we have n factorial divided by n minus R factorial, and here we have R factorial divided by R minus R factorial. And based on this one, we have n factorial divided by n minus R factorial, R factorial. Here we can prove this. Example, how many poker hands of 5 cards can be dealt from a standard deck of 52 cards? Because the order in which the cards are dealt is not important, the number of 5 card hand is combination of 52 and 5, which is 52, 5, and 47. This means 52 minus 5 factorial. Another example, how many ways are there? 47 of. So combination of 52 and 47 gives you 2,598,960. Corollary, let n and r be some non-negative integer and r less than n. Then combination of n and r equals to combination of n and n minus r. How do we prove this one? Based on the theorem that we had already, we say that C of n and r equals to n factorial divided by n minus r factorial multiply r factorial. Then we can say that C of n minus r equals to n factorial divided by n minus r factorial n minus r factorial. And if you just simplify it, we will have n factorial divided by n minus r factorial r factorial. And we can say that these two are equal. Example, how many ways are there to select 5 players from a 10-member tennis team to make a trip to match at another school? The number of combination. Combination of 10 and 5, 10 factorial divided by 5 factorial, 5 factorial. 10 minus 5 is 5 factorial, right? This is n minus r. This is r. A group of 30 people have been trained as astronauts to go to a first mission to Mars. These people are astronauts. How many ways are there to select the crew of 6 people to go to this mission? The number of possible is 30 and 6. Very simple, you can calculate it. And again, this 24 is 30 minus 6 factorial. The last topic is binomial coefficient and identities. A binomial expression is the sum of 2 terms like x plus y. We can use counting principle to find the coefficient in expression of, for example, x plus y power of n or 3 or anything. For example, if you want to consider x plus y cube, then we can say this is equal to x plus y multiply x plus y multiply x plus y. This expands into sum of terms that are product of those 3 numbers that we have. Then this one will bring to this x cube, if you do this multiplication, x2y, xy to the 2, and y to the 3. Then the question is, what are the coefficients? To obtain x3 coefficient, an x must be chosen from the sum. There is only one way to do this, so the coefficient for this one is 1. To obtain x to the 2y, an x must be chosen from 2 of the sum and y from the another, so we can say combination of 3 and 2. Ways to do this, and we can say this is 3. To obtain x y to the 2, an x must be chosen from the sum and y from the other 2, so we can say combination of 3 and 1, which give us 3. To obtain y to the 3, a y must be chosen from each of the sum. There is only one way to do this, so we can have only 1. And we have used a counting argument in power, this is in power, which is this one, and we give us this combination. We can say simply x plus y to the 3 is equal to x plus y multiply x plus y multiply x plus y. Then this, if you do the multiplication, we have x plus xy plus yx plus yy multiply x plus y. We did this one. Then if you do this multiplication by this one, we will have xxx plus xxy plus xyy plus yxx plus yxy plus yyx plus yyy. It gives us x3 plus 3x2y plus 3xy2 plus y3. If we have x and y as like variables and n is a non-negative integer, Then x plus y to the n is sum of from j to 0 to n combination of j and n x in power of n minus j y in power of j. This equals to combination of 0 n x n plus combination of 1 and n x n minus 1 y up to here. For proof, we use combinatorial reasoning. The term is the expression of x plus y in power of n. These are in the form of, like, for example, n in power of n minus j, y in power of j. And j can be 0, 1, 2, up to n. To form the term like this one, it's necessary to choose n minus j x's from n sum. Therefore, the coefficient of n minus j yj is what? N and n minus j combination, which is equal to n and j. Here is an example, the last example. What is the expansion of x plus y to the 4? Using binomial theorem, x plus y to the 4 is j from 0 to 4, combination of 4 and j, x to the 4 minus j, yj. So we go, this combination of 0 and 4, x to the 4. Combination of y and 4, x to the 3y plus combination of 2 and 4, x to the 2, y to the 2 plus combination of 3 and 4, x, y to the 3, multiply 4 and 4, y to the 4, which gives you this one. So this was a lecture about combination and permutation and binomial. I hope you understand the topic, and please feel free to ask me if you have any question. Thank you.